Okay, good afternoon to all of you. Welcome to the session. Today, I plan to discuss the next section. The next section will be, let me share the screen. Yes, hope you can see that. Communities turn off, yeah. So the next section is the comparison of software development processes. So what I hope some of you may have gotten a chance to go through the slides as well as the recording I have uploaded. I will go a little bit more than what is given there, and also would like to discuss with you what is given here. So this topic is about the evolution of software development process models and kind of a comparison. So we will discuss in detail some more of the things. I will keep the mic, the camera off because my internet connection is not very stable sometimes. Okay, yeah. So the video contains all what I have explained in detail about the things what is given in the slide. So you can leisurely go through if you have a time. But let me discuss the key points. Okay, the key points, and also would like to see how it works in the context, and also prefer to get your input in and some experience, because a majority of the people are in the software industry, therefore hope you can also contribute. Okay, process models. When you read this thing called the process models, what does it mean? Process and a model, two things. Are they two things or one thing? What is the difference between a process and a model? What is a process? If you simply looked at the definition. So any work when we are going to do, okay, there is a process to be carried out. I mean, every work, and if we really want to produce something at the end, there is a process we may follow. Even if we look at day-to-day work, I see the biggest process that takes place in every house is cooking. Cooking is a kind of a process. So people will have to follow that process to produce something. And in that process, do we have a model? Yes, there is a model. I mean, that model is what people follow. I mean, in Sri Lanka, Sri Lankan, the taste, okay, usually rice and curry. Usually people have it as the main food, and there is a model to prepare it. And people follow this model. They do the process. They adopt this model to carry out the process, to produce what they want. However, the model, when people start applying, they may customize, they may modify it based on their experience, based on their requirement, and the people may change. This model is again, okay, vary from from one particular group of people to another particular group of people. Now, usually the cultural, geographical reasons and the community that defines usually an abstract model. And people practice that model. The taste of the food prepared in one particular area, okay? Even in the same culture, if you go and look at in the Sinhala family, and if you go for a completely different parts of area, their taste will be different, and most of the time in that area, that may be what they like or what they practice. So model, I mean, in everyday life, what we see, this model is what we adopt a model when we carry it out in a process. And then it's much more easier. But when the people have more and more experience, they change it. Same happens in every kitchen. Okay. And when it comes to the software development, we have the same setup. The processes are very, very important for the software development. And people follow a kind of a model to produce the software. So that's a kind of a very abstract thing I just would like to say. If there isn't any question, I'm really welcome. If someone has a comment or even a question, I'm very happy. You can ask or you can put in the chat box if you feel it more comfortable. So process models, when we go there, now then the next question which comes to their mind. Now, model, when we say a model in the software development, how many models are there? What are these models? I think it's a very common thing. I mean, these are some of the popular things. I mean, everybody may have learned all these things, even in this. My idea is to not to go into the detail. The idea is to analyze these models and then see how evolution is taking place. Everyone may have learned, heard, and practiced and seen the waterfall model. Okay. That is the very first, very popular model. People adopt and follow in the software development. And after that, there are so many other models comes. Okay. My objective is not to discuss every model, but I would like to see your participation, analyze them, and see how these models are being challenged and modified. Okay, we will see in this discussion. Now, when we say evolution of the models, it means the waterfall is a very popular, but later people started going to the other models. Why? What is the reason? From time to time, people go from one model to another model. Every model has a lifetime. What is the reason for it? Why people change the model? Can someone say the reason for adopting new models or going for another models? Why?
It consumes too much of time.
Yeah, you have a good kind of a suggestion. That's one reason. There may be some problem. That means if you follow the model, there is a kind of a problem, as you mentioned. It may consume more time. So then the people have a problem of following that model because the output may not be into the standard or level, but they really, if they have to spend more time because of the model, then naturally they may go for a new model. Yes, that may be the one reason. So there are a few things. In a waterfall, has to complete one step to go to another step. Yes, that's the waterfall. But moving from waterfall to the other, what would be the reason? Then there is another comment saying rapidly changing requirements. Are we changing the model because the requirements are being changed? Or is there some other reasons? Limitations. Yes, limitations. Every model has a limitation. But if you carefully looked at why we go for a model to produce a product, or what we call the software, when a given set of requirements and a given set of requirement that we have. But if we fail to achieve what we want, then this model is not good. So then we have to change our model. Model is a kind of a tool, in other words, which people use during the process. Can't go back to the finished stage of the development. Some models may not suit for the particular situation. Yes, some model, yeah, the model are not good because of the different situation. So then selecting the suitable model is also a challenging task. If you select the wrong model, then probably you may not be able to achieve the what you really plan for it. Yes. Then when we talked about these models, and the models are, lots of models are being now proposed, and we may have to think about why there are so many models comes. So evolution of the models from the waterfall to the new sets of models are there. So the waterfall I'm not going to discuss. There are basically several stages. Why we call it a waterfall? It's very beautiful. Waterfalls are very beautiful. When you look at from the outside, everybody like to enjoy and relax and see it's a very attractive waterfall model. So even the software development is very attractive. But what is the problem with that? Yeah, so technically you can say can't go back. Waterfalls are very dangerous things. If you make one mistake, what will happen? That is the end of the everything. So the risk is very, very high in the waterfall. That is what we say in the general life. Lots of people die when they go to enjoy and watch the waterfalls. So the same thing comes in the software industry, software world. The waterfall model in the software is also very, very dangerous, very, very high. The risk is very high. That means if people make mistakes, and that's the end. They can't control, they can't come back. Once you go down, that is the end. So you can only move forward, very hard to come back. Risk is the kind of a very tough thing that we have to manage from beginning to the end. And the waterfall model doesn't provide a mechanism for us to manage that risk. So that is the one thing. I mean, there are so many other reasons that you can find why waterfall model is not good and what are the challenges. But still remember, waterfall model is still being used. Lots of things what we do, it's have a flavor of the waterfall model. I hope everyone, okay, there is some of the things I have put. Before I go to the next one, I have one more question. What is the software development life cycle, SDLC? I mean, this is not a new term to all of you. What is a SDLC? Is it a model? Is it a process? Or is it something else? What is your view? Process. A process of a software engineer, software development. A process. Well, yes, software development life cycle is another term which we use to describe this process. But in SDLC, software development life cycle, what we see is mainly a set of stages. There are stages where people have to pass through when they develop a particular system. In other words, if we carefully look at, irrespective of the model that we adopt, software development life cycle has stages where people move from one stage to another stage. That is what we see in this process. Okay, and it doesn't say whether you can go back or not, but in high level way, we identify in the SDLC stages in this process. So what are these stages? People could describe at different levels of the details, but in general, how many stages you see in the SDLC? Can you remember? What is the first stage? Planning to deployment. Yes, there is the beginning, you can say planning. The end, you can't say the deployment. After the deployment, there may be something more. The high level status people define. What are the main stages that you see in the SDLC? First, I think the biggest one is this planning as well as the requirement gathering and analyzing, and then make sure what they really wanted to do. Now I'm talking about in a very high level way. So that may also include in a kind of some sort of planning. Sometimes people consider those two things as two separate stages. So after that, people go to what we call, yes, the designing and implementation, or what we simply call the development. And at the end, people do a kind of testing as a kind of a part. Okay, that may be part of the development, or even there may be another testing, what we call the testing of validation of the system, evaluation of the system based on the initial requirement. That's what people usually do. And then if that is quite okay, if people are happy about what they have developed, they put into the operational mode. That's what we call the deployment. That's the next stage. Okay, some of these phases are not happening one after another. They happen in parallel. That means you don't want to wait to start the other phase. I mean, no need to complete in one phase to start the other phase. I mean, sometimes there could be overlapping stages. That's also we can see in the software development lifecycle. But that's stages in the whole cycle. And then after deployment, the story is not going to end, as we all know, where the people will have to maintain it. There may be a routine maintenance, because otherwise there could be lots of operational problems could happen. And there may be a maintenance to make some modification, changes to be done. And then probably that maintenance work has to be done during after the deployment as a part of a running software. Okay. And one mistake, but I think most of the time, people hardly think about the beginning and end. You know that if we purchase some sort of a physical object, we know after a particular level, the product comes to an end. Give me the 1 minute, please. Sorry. So I was talking about the software life cycle. In a life cycle, when we say the life cycle, the beginning and end is both. People don't think about the end. People wait until it dies. But we have to think about, and every software product has some period of life. That's the period of life what we define or discuss in the software development life cycle. There is an end, definitely. And after the end, if you try to use it, it becomes more and more problematic. And that's what even in the previous section we discussed about this legacy thing. So after one particular stage, every product becomes a kind of a legacy. So it is very similar to the old people can't be productive like a young people. So everybody will face, okay, you and I both, all of us are moving to that direction. Every day throughout our life will not be same as the way we do it today. But then that's something people really need to think about. Most of the time, what happens when the people make an investment, when they buy a product, they hardly think, they think forever they can use this. No, always need to better to think about how long. Maybe after 10 years, they may have to re-engineer the product or redevelop the product again or buy in a new product. We'll have to move for that due to maybe several reasons. One reason may be the requirement changes. The other reason may be the environmental changes. Okay, operating environment may have changed, and there may be lots of problems like that. So in the software development life cycle is another interesting thing what we see there is the beginning and end. And this beginning and end, we identified the several stages. And software moves from all these stages until it comes to the end. Okay. And but that is the life cycle. But these models we consider usually to develop and put them into the operational. So life cycle and a model are not the same. So that's, I hope it's clear to you. Then those are the you can have, when you search on the literature, there are lots of people describe the life cycle in a different ways. Yes. Then other thing that I wanted to discuss today is the waterfall became very popular at very beginning, but later it was challenged and the people start talking so many issues. And then there was another thing. I mean, there was a lots of new models people prepared. What happens when we have on a model, when there is a problem, people come with a new kind of a proposal as in a new model. Lots of R&D work. Even today, you see, I mean, I think we have an infinite number of software development models. Okay, so here, what we see, the process, the models. Okay, another model development phase is based on the waterfall model. Another popular thing appears in the software industry is what we call the incremental approach. How do you see the incremental approach? Is the same as in a waterfall model, or is it something different? What is your idea? I mean, I can say a lot of things, but I like to hear the others' opinion. How do you see the incremental approach? How do you compare the incremental approach? Is it another waterfall type model, or it is in a high level group of a model?
You can say or you can type. How do you see the incremental approach? What is that? It is something related to the waterfall. It is something different. Why it has become a very popular approach? People consider. Risk is low. Risk is low. How do you say risk is low? Jumping from a very big waterfall is really risky, but you can jump in a very small, no need even a waterfalls you can see in your garden sometimes, but they are not really in a waterfalls. They are very smaller flows of the water in somewhere, something like that. If it is not very dangerous, then you don't mind about the risk. So in a way, to some extent, we are trying to say, yes, risk is low, and also flexible. What do you mean by flexible? What is this? What is an incremental? In the waterfall model, waterfall is a kind of on a very high level category of the different software model. Even it was proposed as an initial model, but then the lots of people came with a lot of differences. But the issue is the waterfall model is based on the high level stages in the software development. And you move from that one stage to another stage, okay? And you are trying to do it. It's in a what we call the big army moving from one place to another place. So it's in a kind of in a large scale movement from one phase to another phase. So then it's a very hard to go back. But in incremental way, we don't think about everything at once. We think about small part, okay? And we consider the development by adding one feature at a time, then trying to integrate them, okay? Lots of people said several things I didn't miss, so I like to read what you said. Improved efficiency, multiple development life cycle divided to one smaller modules, can return early stages, develop modules, in an incremental way. High priority requirements are considered first. Incremental model allows to identify the issues, stakeholder feedbacks in the regular intervals before the reusing. Simple, manage the risk because handle, go back to the process very and start. Delivery features one by one to a whole system from initial implementation to exposing the user feedback. Have some SLD steps, but some software develops several phases, working versions, software, entire work divided into set of waterfall models. After every increment, working pieces of the software available, unlike waterfall. Overlapping phases are possible, linear and the parallel workflow. Different ideas, good. But in increment, I mean, whenever we wanted to build a big thing, if you try to think everything at once, that's a big challenge. But you know that you have to develop a big thing, but you start step by step. You work on a step. You take in a smaller step, you do it. Then you take the next step, you develop that one. Then if you are quite happy with the two steps, then you try to integrate that one. I mean, most of the development works are like that. Even if you look at the way how we build a house, there are many increments. People start with the foundation. That's the one increment. People that's the first thing they will have to do. And they complete that thing. And the people, when they are quite familiar with that one. But you can't put the foundation if you don't have a big idea what type of house that you are going to build. What sort of a thing. So, but incremental thing is the approach that we follow. But remember, it doesn't mean still you need to have done the lean requirement analysis, you should know the big picture. But then you work on a one-by-one increment. Sometimes some increments you don't want to wait to start the next one. You can start in parallel. Sometimes somewhere in the middle you can start. And depending on the resource availability, other things can start. And this will gradually make a big work. And you can, if you have more resources, you can speed up the process. So the incremental approach becomes very popular because the waterfall is what we call the army walkthrough to a kind of a war type of a model, but incremental is in a very gradual stage where people move from one step-by-step approach. So it became a very popular in the software development model, and this approach based on this one, I mean the many models people decided to adopt this incremental as an important method when developing the software development model. So that is one thing I just wanted to say, a method. A method means increment. It's like even the people later talked about the versioning, different version. Every later people define an increment as a version, and people start releasing the product by creating the versions and then doing the other thing. Okay, but at the same time, now increment work on a one way where you develop the one thing, then you go to the next feature, then you go, it's a little by little. But at the same time, people start working on another way. They start in another. So this is where we talked about the incremental approach, incremental development model. Okay, lots of people start talking about, and even there. And also, I think it's if you look back, what is the rapid application development model? I explained in even the presentation. It's where you identify the set of an increments you wanted to do within the short period of time, 60 to 90 days. And in parallel, you also use lots of tools, machinery, and the ready-made stuff. And you wanted to, main thing is this 3 months job. Okay, that's only what you have, and you use all the tools and other things and finish the job, and you wanted to get something, okay, like in a prototype, a working thing you wanted to show. That is the main reason why the RAD became very popular. Okay, rather than putting in huge investments, quickly people do it. I still say today the RAD is the beginning of Agile. Later, now people talked about Agile, but RAD was very popular at one stage. Even the 1990s, I remember lots of tools came. Even if you may have heard, the Visual Basic became very popular at that time. We were students at that time. Okay, in the early that's time, and the people think about. I remember Visual Basic became a very popular Microsoft product, and people say that is in a quick way. Even the 4GL, fourth generation languages people talk about, rather than where you do this 3GL approach of the programming, where you drag and drop the components and quickly develop the systems you want. And people think that is the way forward in the software development model. And the RAD model is in a kind of in a beginning, and the people think so. Parallel processing of the iterative process is incremental. Parallel of the incremental process is the rapid application development. So the RAD model, the details we discuss in that way. What is this? What is the evolutionary model? What does it mean? Okay. Suppose you have to run a race, not a race, or kind of a sports event, maybe 100 meters, or not 100 meters, 1,000 meters or 1,500 meters race. then you will have to run the whole the perimeter of the ground. And it's a harder thing if you have never run before. So you have to do a lot of practices. So how do you do it? If you try to run in a big round in the ground, I mean, you may not be able to run even half. But think about a way you start running somewhere in the middle, smaller circle, and you run and see whether you can really run and what is the problem. What are you, whether you should run very fast, where you have to be very careful. And then you increase the perimeter of the race or the run. Gradually you start increasing. Then what becomes? At the end, you become a capable person to run a full round on the ground. But then you have started from a small circle and you have gone to a bigger circle where now you can run. You may start within 100 meters, but gradually you may go for 1,500 meters when you increase the radius of your circle of running. So that is also a kind of a model where you can reduce the risk. So do a small thing. I mean, don't try to take it everything. Okay, run a small round and then gradually start increasing. So this also became a very popular approach. People have to think about it when they wanted to come up with the models. And what we saw later, I mean, lots of things in the nature is something like that. For example, if you look at small plant, let's say it's a mango plant, or mango plant is quite okay. It's if you look at, it's not a big tree, it's a small plant, but you see all the main features in that small plant, in a mango plant, leaves and it's the shape and everything. But let's say after 5 years or 10 years, this small plant may become a big tree. And it will have, still will have the initial features you can see, but its size is really big and it's very strong. And it has so many products and people like it. At beginning, you can jump over that mango plant, but now you have to climb the mango plant later on the tree. So the developments also have that approach. I mean, it's a gradually grows. That's what we call growing, evolution. Evolutions are they become a bigger things with the time. That's another approach. So they start with what we call the core features you can see at the beginning, then you develop that one to a large structure. And the people found this is also a very interesting approach for the development. And the best example that was shown is what we see, the prototyping, as well as a prototyping isn't one thing, but more than the prototyping, I think is I have the spiral. I'll come here. Spiral is the most popular thing which shows this evolutionary model. So software development models, when you start analyzing, you see some of the models have this kind of an approach, whether it is an incremental approach, whether it is an evolutionary approach. And the people start follow these two cultures in the inventing or proposing the new models. Then what we see is even at a later stage, I think if you read the literature, some people see incremental has some advantages. Evolutionary has another set of advantages. Can't we combine these two things? People describe one direction, incremental, as in a one-dimensional, okay? One-dimensional approach in the software models. So they want to bring this both dimension into one and then call it two-dimensional, or known as a hybrid models for the software development. So people had many experiment, and there was a nice model, the very first two-dimensional model for software development. What is that? What is the name of that? Can someone say? What is the first two-dimensional software development model? It's an open question for anyone. Have you heard something called rational unified process? RUP, a very popular term. Yes. Rational unified process. This was proposed somewhere in the 90s. Okay. When this was proposed, I remember it became a very big discussion thing. We were, remember students and the final year students at that time when the RUP was first, we didn't have an internet or anything. Sometimes there are some workshops, there are some discussions, some people says, and hardly we get in the books even to the UCSC at that time, and very difficult to find the information. But the RUP came as a kind of a very interesting model for the software development. And we didn't really understand what does it mean RUP, and we thought, okay, another Visual Basic type of a model. Another company, Rational Rose, is the company which was known as which proposed this one, which came kind of a process model where people talked. But the rational unified process came with another discussion, another set of a thing. That is what we still today practice, UML. Unified modeling language, UML, is in a unified model. It's in a set of annotations which people can put these, creating the visual structures. I mean, one of the biggest problem is if you write the requirement in words, people can't understand. It's a very difficult. One picture could communicate a big message, as we all know. So putting the requirement at one stage, people say, okay, you can't understand, this is wrong. Every time so people say wrong. So try to put some graphical thing, then use those graphical thing to interact with the people. Unified modeling language. And then the biggest issue, what happened at that time, different people start coming with a different notations. Okay, there is no uniform kind of a notation. Even the data flow diagrams, data flow flow charts, and those notations was very popular at that time. People were using it, but then people wanted to, especially this is also linked with the object-oriented approaches. I'll come back to that topic sometimes later. Object-oriented is the key thing which initiated all these things. Object-oriented is not a software development process model. Don't mistake that one. It's another methodology and paradigm. I'll discuss that one at next 2 lectures about the object-oriented software engineering. We have it, but here the rational unified process was proposed as a way to overcome the problem industry faced due to the traditional waterfall model. Okay, the first thing was the incremental, then the people start moving on the red and the Visual Basic, I remember. But the RUP is more favored to the object-oriented. But again, it comes with another thing, UML. And the many people, even I remember I was also confused. UML, I thought the UML is part of the RUP. No, UML is in a notational language. UML is also nothing much to do with the language, to the model. It's a notational thing. Then object orientation was the background which helped them to happen. So these three things is a very important development that took place during the 90s. And then it's went further, more development. The spiral development. So there, and so many different things start coming. And the unified process is a kind of an abstract one, because the rational unified process is a very a kind of a proprietary model. People talk, even today you find so many proprietary model, but then people want to have a kind of an abstract model where not depending on a particular company, where people can independent. So it's the unified process games, and it's defined as, use case driven, architecture centric, iterative, incremental. And it's not only two-dimensional, it's backed by another two tools. What are these tools? Use case driven. Then the architecture centric. And then closely aligned with the unified modeling language, UML. So this is the where the thing came. And at the same time, there are so many other things. The formal methods, I'm not going to discuss. The formal methods emphasize the mathematical specification of the requirements, because the waterfall has a big criticism, saying they are not very, it's not very formalized. It's a very high level. So the formal methods are more theoretical. It never became a formalized, even though it's a formal method. It's very tough, and the more theoretical approach in the software development model, you can refer and learn and discuss. And then, I mean, this is the one direction where this comes. And there was another thing start happening. That is where the people really wanted to develop the software models using what they have already done. Because there was another thing people say, I mean, I am repeating the same thing what we did. Can I reduce? Can I get a model where I can reduce the repetitions of the work? So then I think the software reuse, the reusability is a very important quality factor, people so call. And at the same time, if we usually, it's a good practice to encourage people to reuse the thing, then you can reduce the cost, you can reduce the time, and you can do it. But hardly we find incremental or iterative approaches doesn't directly promote the reuse. So is there a kind of a model which can you promote kind of a reuse? So what we call the reuse existing component. So here, component-based development, people talked about. It's another thing came in this software process models, where software reuse became a very important practice in that context. And people call it, sometimes it's an integration and configuration approach, okay? And you identified the whole these things. So some of the parts you directly reused. And if you carefully look at some increments, you completely taken a module. So you don't want to develop. It's a ready-made thing you put into there. So good and bad things comes when you reuse a bigger component. And even that kind of a modular-based, component-based approach in the development became very, very popular. And even this beans, okay, the concept of the beans is also came within a Java. On the other hand, it's came with a kind of a component-based approach. So that's also became a very popular one. And then whole this whole landscape of what I say, the software development models became a very large and a very complex. And what still today, identifying the correct model is very, very challenging. The most of the time people realize they selected the wrong model somewhere in the middle of the project, but then it's too late. It's like the way we understand many mistakes we make in our life later in the life, but then it is too late to correct. You have to live with the mistakes. So like that, software engineering, we see that's the process model evolution is based on it. Aspect-oriented software development. Have you ever heard? This is a debatable, I mean, they're not very popular today, but it's a very good thing if you have a time to investigate and learn. Object and aspect are two concepts. Sometimes people think object is in a kind of you are trying to modularize in a particular thing, but aspect is depends on the way how you look at the same thing. The same object could have two different aspects. It's a way how its interfaces work on that one. So then that's another very good proposal, and there was lots of even the programming languages, aspect-oriented programming languages was proposed, software development models, people taught. And yes, there are lots of interesting work happened. But anyway, RUP and later what we call the unified process became a more popular approach because it's a two-dimensional model, what we see in that context. Then this one, the most another thing happened is the use case driven is in the UML influence came. What is in a use case? Why use case is so much given in the popularity? What is the reason? Technical people want to describe the requirement from the system point of view, but general people don't understand. People want when we say user requirement, you have to present it in the way the user, what the user want. So in the use cases, where you present the requirement from the user's point of view, how the user wants, how the user is using it. So that is the main theory behind the use cases. So where you try to, I mean, the most challenging thing still in the software industry is the identification of the requirement, whatever the model you use. If you identify the things in a wrong way, it is not going to be a fault on the model or the process. You got a wrong thing, then rest of the thing you will have to fake lots of mistakes. So if there is a use case, is in a kind of in a way where you try to look at from the end user's point of view. So try to get this thing into the process. People thought it's really very important. Why this? What is this? Something called architecture centering. Can someone say why? What is the reason for this? What's the meaning of that? Why so that? Why such an emphasis is given for the architecture? in a process? What do you think? Happy to give all of you a couple of minutes to think about. Just say it, or you can put your ideas on the chat box, or always welcome if you can say.
Architecture. Why architecture is so important? Whether it is an OOP or structure, the development, what we do should compatible with the future. Think ahead development. So the architecture, what we built, should be compatible. Okay, that's one suggestion. Now we realize one of the biggest challenge in the software development is the identification of the requirement. Most of the time, as I said, as we all know, you make mistakes. You identify the wrong requirement or you go in a wrong direction. But later you realize this is not what they want. You have to correct. But most of the time, when you realize you have to correct that one, the biggest issue, the foundation of your system, if it is not capable to accommodate those changes, everything will collapse. It's something like based on the requirement, you identify the client needs in a one-story house. But suppose if you put in a foundation for a two-story house and you build in a one-story house, no harm. But somewhere later, if the client say, no, I also need something like that. And then they may go for he wants to go for a 2 stories. He thinks I also thought about it. I said it in different way. Then the structural engineer will be in a big problem if the foundation is not good enough for that. So if the structural engineer in that case is a very capable person who may think, because always one of the problem in the requirement engineering section we may discuss, we see only 50% of the what comes in the requirement. We don't see the whole everything. We see only a part of it. Then later the development team will discover lots of new requirements. And so architecture, if it is strong enough, it's there. Usually we build the architecture based on the requirement what we know. But if there is no harm and it is recommended to have a little bit of a strong architecture because the requirement could change. This happens in the many places. Even I remember several buildings of the UCSC. We had 3 stories and the 4 stories, and later in one stage we wanted to make them all to the 5 stories, and then there was a big issue of with respect to the architecture. Fortunately, people have so many suggestions and they have done it. So the same comes here. Architecture is the foundation. But there is also another challenge now. This is which comes in the what is known as a very popular thing called the don't over-engineer something. What do you mean by over-engineering? Over-engineering means trying to put in a foundation for an unacceptable and trying to make it a perfect thing for everything. Okay. Always we need to be practical. If you try to think about every possible thing, and if you try to do a perfect thing, that's what we call generally over engineering, trying to accommodate. So when we say architecture centric, that means we are really focusing on the architecture, very important thing in this process, identifying and putting. Usually architect is a very senior person who make this decision by looking at the overall requirement. He doesn't need to go for all the detailed requirement at a very beginning level, people make it. And then they consider these two things as a very important supporting tools in this process. And then follow the incremental and iterative both together. That's the unified process. Unified process is the abstract version of the RUP. It's not the same as a RUP. I'll show you the later the RUP, and this one is how really it works. But the process works in that way, and people found it's in a very challenging, but it's a very promising way to move forward compared to the traditional waterfall model, and became a more interest. And then the good thing is the unified process became an abstract model, abstract process model. That means when I say abstract process model, why we call it abstract? Because someone can take an abstract thing and extend that one in a particular, based on a particular overall culture. In other words, organizations have what they call that they are on cultures. An organization can take an UP and customize to that suits for their organization culture, the software development culture, even bringing the other tools inside. And this process models are just not on a high level description saying you do this and that and those things. It also comes with lots of tools, techniques, documentation, templates, use case driven architecture centric, and the UML documentation and the templates and everything is there. So then only you can automate the process. Automation is very, very important, especially if you wanted to increase the productivity and if you wanted to take more. So this is the very high level evolution that took place to make it. Even the software development, people wanted to automate to some extent by putting some lots of tools. Have you heard something called the CASE tool? CASE means computer aided software engineering. What is that? What is a CASE? Computer aided software engineering. Anyone willing to say something? Yes, CASE tool. Yes, you are correct what you said. Earlier people thought about this in a kind of a machinery to create the code from the design. That's what the main thing. Then even automate integration of the test automation also plug, and people wanted to automate because it's a more on the human centric. labor intensive, we call it. It's not good, then you really need to bring some machinery. And then people were trying to automation is the where you can reduce some sort of a way to do it. And people really wanted to take the things forward by through that kind of a mechanism, kind of a tools. Then you get a sort of templates, documentation, specification. Things becomes in a more formalized approach in there. Okay. So this is what I just mentioned there. So in the unified process, not like the waterfall, you see 4 things. What are these 4 stages? It's called the inception, elaboration, construction, transition. The 4 phases are there. But then the 4 phases on a generic phase framework. So if you like this one, this is the UP processes, but more better thing I have it somewhere else, I think. I'll come back to this one. Unified process, didn't I have a picture somewhere? No. I had some maybe in the somewhere else. Now in the unified process, yeah. So you see the 2 dimensions, okay? One dimension is where the stages of the work. That's what we saw in the main thing it goes. I mean, the workflows we define, the requirements, okay, gathering, and then analysis, then the design, implementation, testing, and the support, maybe the maintenance part. That's the main stages. And these stages, you have on several phases, okay? And on the other hand, so the phase, here you see the more and more work, it becomes the workload goes very high. It's an active period, goes for an almost 3 phases. Then the analysis started a little later. It's yes, that's a design is also with that. Implementation is, well, once you don't want it to wait until this finishes, okay, it overlaps. And the testing also you start at an early stage, and the support is also may start and after deployment. There isn't a better picture for the RUP, but unified process, I mean, to get an overall view, how these 2 dimensions are linked together. So there you see the inception is in a very beginning phase. And that is the phase where you discuss the basic things, what the people do, okay? Identify the business requirement, the initial rough architecture, plan for a number of increments and the phases. And then elaboration is the kind of where you elaborate to expand the things and create the larger one, creating the models and then refining the use case model and then doing it, and probably you come out with an executable architecture baseline. So how this is built and created. Review plan, scope, risk, and the delivery dates. Okay, construction phases, the transition phase, and the workflows distributed all over the UP phases, a workflow, and the work products. I mean, the lots of things, documentation, tools the people produce. So, for example, inception phase, what are the things, what are the intermediate things people generate, like the vision document, okay, initial use cases, initial project glossary, business case, risk assessment, okay, project plan, the basic one, initial, business model, many things. I mean, this is a small list. And then the elaboration phase, you see that sometimes the same things come with more details, more better version of the thing. Then analysis model, software architecture, executable architecture, preliminary design, revised list, project plan. And so more things are added. Some of the things here done is revised here. So because it's an iterative process. Construction is where the people develop, and the transition are where they deploy. So the work products comes, I mean, in a particular implementation of the, I mean, the particular concrete unified process. RUP is in a concrete unified process, rational unified process. It comes with all these things. It's proprietary, but IBM later took it, and almost today the things are freely available, most of the things, but still people can work on it. So this is the where the unified process and its games. Now, my question, does it solve all the problem what we see in the software development model? Now we bring the iterative, we bring the incremental, we bring the lots of tools. My question, has it solved the problem that we faced in the software development, the process models, in other words? What is you think? What do you think? What is the missing? Why people later realize? I mean, the iterative incremental is a very good. All these things are fine. Theoretically, right way to do things. Yes. But at the same time, there is a challenge. What is the challenge? What is the challenge? Can you think about what is the challenge? One thing is missing. Big Bang approach is one thing I forgot to say this. This is the way waterfall follow the Big Bang approach. It's called. I mean the army approach, entire system development at once. But one thing is still missing. We talked about the 2-dimensional. Later, actually, people talked about the 3-dimensional software development model. They brought in one thing. What was that? Can someone at least a guess what was that? In the industry, lots of people doesn't entirely solve, but reduce the complications. Yes, I agree. But where the complication comes, what is the complication? What is the main problem? The main problem is the people. You can have nice models, but it is something like a... Sorry, I was disconnected and came back. Hope you can hear me. Am I correct? Hello?
Yeah, I can hear you.
Yes. Thank you. So my question is, we talked about the 2-dimension, but what about the biggest? There was still a biggest problem. You do all these things, but there is a problem. Problem is the people. You have a nice methodology, model, processes, tools, approaches, but if the person is unable to follow. Okay, once again disconnected. Hope I'm back. Am I audible? You can see me? Can hear? Can you hear?
Yes, sir.
Okay, thank you. Okay, so I was trying to say the problem with the 2-dimensional approach. Okay, unified process is a theoretically nice model. But then the model is nice and you have a good way to manage tools and the supporting tools, environment. But if the people are weak or if they are not capable to do that one, what will happen? There may be lots of other problems people will face. I mean, the success of the kitchen depends on not the equipments and the ingredients in the kitchen, the person who cooks the meal. If the person is capable, if the person is smart, the success is entirely on him. But it doesn't underline or it doesn't say that you don't need a good kitchen with the instruments and the tools and the ingredient. The person can't make, take or create, make a good, delicious food without those things. But the personal capabilities matters a lot. So in that context, what comes? What is the third dimension? What is the third dimension in the software development model? Can you guess? The most popular term in the software engineering today.
The graphical.
The graphical things are another tool, but Agile was introduced mainly because this capabilities and incapabilities of the people who participate in the process. It's the where we try to change the model, sometimes fine-tune the models, what you can do. If we have a nice model where people can't do it, the model is unsuccessful. We always need a model. The success of the model depends on the people who practice it. Then the model should be customized, or model should be in a way to be modified depending on the people, what they can do. There may be lots of parameters which controls them. So the agile practices, people brought it here. Now, even if you search it, lots of model people talked where these three things people consider: incremental, iterative, and agile practices. So one of the interesting things to search, you can find agile unified process. Okay. So where they brought another dimension, that's the agility, okay, into the practices. We discuss about the agile later on, but that also people can use to propose and adopt new models. So if you search and do a kind of a literature survey, you will find today so many new models. I mean, lots of people are coming with so many new ideas, practices, experiment, R&D work. Even some companies they are proprietary. I mean, today the software development models, some people have put saying this is our model. They have put in a copyright for the model. It's a proprietary model. And they even, several companies in Sri Lanka also, okay, they say this is our model. They have a code name even for the model. And the basis, the foundation, maybe unified process. And then they have added lots of tools and the other things to make it more capable. So the next one, I wanted to say. Yeah, so incremental one, I have some other things. Iteratives means the network rescheduling strategy, typical one. I mean the very good example I have now. Suppose you can use the incremental to build a house. Can you use the iterative approach to build a house? If you have to use an iterative approach, you have to start with a small hut. You will build a hut and next day you will break it into the pieces. And you may build a better hut on the next round. And you are trying to build a hut, a big house through that approach. Some of the things doesn't work at all. So the product has something. So some activities you can follow the iterative, but the overall philosophy has some issues. Yes, but you can mix incremental and iterative. UP is the way people have. It has a unified process, business modeling. It called here come. It's a nice diagram which I wanted to show you. This is the iterative development. This got it from the yeah. So even if you looked at the business modeling, requirement analysis, implementation, test, deployment, those things, how things actually work with the time. You have the one. Here is the RUP. RUP comes within a different set of disciplines. That's the workflows. Sorry. Thank you. I'm not sharing. I forget it to share. Sorry. You can see. Can you see now? Very sorry. I'll go back, which I wanted to show. Incremental, I was talking about the incremental approach, scheduling, and stacking strategy, it's called. Big Bang is a kind of an army approach, which I told you earlier. And then the iterative is rework, scheduling. And then the kind of a way, that's what example, you can't put an iterative into the sum of the practices. So however, some component development, you can use the iterative. Incremental, the same thing. So where you combine this two-dimensional model, where you put the 4 phases for the one dimension, 6 disciplines for the others, and graphically you can, this is the wiki page, I took this one, they have more details, business requirement, and this is design, implementation, testing as the workflows. Okay, these are the phases, and the bigger phases you can put in a small, what we call the time box. Okay, and then you practice the iterative approach within the C1, C2, C3, C4. 4 iterations within the construction phase. So the people wanted to come again for again the 2 weeks, 2 to 3 weeks, and then trying to do it in that way. So this is the visual picture of how the hybrid 2-dimensional model works. And this is the very first unified process, as I mentioned earlier, rational unified process, where they have a different workflows or disciplines here, 8 as far as 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, 9. And but the 4, the main inception, elaboration, construction, transition. So they're different. So you may find hundreds of the unified processes now. The different people come with so many new things, different disciplines, different phases. Most of the thing I have seen the 4, but there are in some cases 5 or 6 possible. But workflows people change, and people come within several tools, templates, many things to facilitate. And here, why we call this a use case driven and architecture centric, that discussion and risk focus. I think if you remember, when you have to do something what you don't know, the risk is very, very high. That is the biggest challenge in the software engineering, that you have to live with that risk. We know nothing about. Even the daily life, it's something like that. We are living in a very risky period of life. No one knows what will happen tomorrow. Even we don't know whether we will have to have the lecture next week. So many uncertainties are there. But in the software world is there. But what is most important thing? You can, I mean, the risk you can't overcome, but if you know the risk, you can work on them. You can identify the critical risk and how you actually can address them. That is the most important, the practice, what the engineer is supposed to address. And this is where the resource distribution in the unified project lifecycle. Inception, goals of the inception, some more details you can. I also described some details in my slide video, and you can also have a look at on that. And then history, I mean, my history is not completed now. So many things has happened. I would like to give a kind of a very small exercise as a part of this section, where I would like you to do a small literature review to identify what are the new software development models, where we see that all the 3 parameters are being integrated with some more other things. Okay, and where people bring lots of new things into the software development model. And the most interesting thing I have seen in the software development, now people are trying to think about bringing machine learning into the software engineering and automating the software development. Then most of you guys will lose the job one day in the future if that happens, but I don't want it to say that it's going to happen very soon. It will take some time, but there are lots of interesting projects. If you search, you can find automated coding. Even the robots, developing the robots who can write programs. Things will be completely different in the future. No one knows the future. In the development of the software, the creation of the software, people think about the different models, approaches, and people think if the model, if you follow the visual model, you can automate easily. You define at a top level the visual model, but you need it. Then the whole construction, maintenance, everything, you automate them. So then, I mean, nothing to worry about. Everything will be created from the beginning to the end. That is the concept people had it. Still, we have failed during the last 20 to 30 years, I think. But now, I don't know what will happen in the 10 or 20 years. There is a possibility things may change. So my discussion is from waterfall to UP, but it is both are now part of a history. Okay, the future is not given here. You have to know about the future. So that is what my small assignment for this one. And also we will open the discussion forum for people to come with the new interesting models for the software development. So many things available. And now what will be? And I like to give another 1-page assignment, 1 or 2 pages. We call it 1 page, is not a 2-page assignment for where you can do some literature review and identify some good novel software development models and how the software development could be enhanced using the new techniques. Most of the time people use the model itself cannot solve all this. Adding tools and even the graphical system model. Generating the code, as we said about this case tool type of thing, then generating the UI. That's also there. Then people talked on the prototyping approach became very famous. The debugging and the IDE on that pin. Interactive integrated development environment. Okay, that is where you see very lots of facilities for people to easily code and see the visually how things are linked. Okay, and the language independent way of working on the virtual machines and trying to get many things up and running. So the best practices is what people will come up with all these models at the end. Manage the risk. That's what people really want to see. Execute your project in iterations. Embrace and manage change. You can't say we have a sign off the requirements. No, you have to still accommodate. Your client is the someone who is paying for this work. He's the someone where you have to develop. You just can't say, I do the right methodology. It's not a good enough justification if you fail to solve his problem. This is the philosophy comes with the idea. Then measure the progress objectively. The progress sometimes people measure with respect to the time spent on that. It's a kind of a meaningless way of measuring. How much do you spend? I mean, if you have not measured the progress in different things, time spent is not the indication of the progress. Test your own code. What does it mean? We believe our codes are correct. What we wrote is always correct. Everything what we have, we think it's correct, but they have so many issues. So then who should test? If you test your own thing, you may not discover a lot of things. Ask someone else to test. Leverage the test automation appropriately. Yeah. So difficult thing is today's culture is to automate. Everyone wants the product. Yes. I mean, most of the time we all do the paid work. You and I, and so then people could share that openly with the others, no harm. Through the sharing, you earn a lot rather than keeping away, even though we may traditionally think, as far as it is hidden, I'm the king. No. Understand the domain. So that is another important thing, not one thing, the whole big picture we call. Describe the requirements from user perspective. Prioritize the requirements for implementation. Too many things. What is the wish list? So different stakeholders have a different wish list. Whom are you going to cater them? It's a tough assignment. Leverage the legacy systems. Yes, everything has a beginning and end. We have to manage not only between those two, even after the death, the others will have to suffer. As you understand, the system life cycle also, if a system dies, many people has to face a problem if others cannot recover. So always we'll have to think about, in this decade, the main theme. What is the main theme of this decade? What is the main theme? Sustainability. What does it mean? sustainability means? If you cannot sustain something, even if you become capable person, but if you can't maintain that capability, even if you become a rich person, let's take it in that way, that is a very numeric thing. Every rich person will be in a poor tomorrow. Always we measure the things based on the others. So sustainability is where you maintain the success. So the development, success, everything, it should be remain, and it should be passed to the other people. We work in an area. So 17 sustainable development goals are defined from the UNESCO, and you can see that one. It's a very interesting thing. Manage versions, yes. Leverage patterns, we'll talk about them more. Architect the components and the services. Actively promote reuse, modify key perspectives, right size your processes, continuously reevaluate what you do. So some of the best practices UP can market, but other things, there are lots of other things that has come. Community-based software development is discussed even in open source. If time permits, I will also discuss this one more detail later in the course. But I just keep it in mind. I'll keep this one as an important reference for all of you. That's the main thing in the section on today's, which I wanted to discuss. Now we need to think about just listening to the things people never learn. Okay. Listening to the nice talks will not help you to learn. So how do you learn? By doing something. Okay. So my suggestion is to go here. Wait a second, I'll share the screen once again, otherwise I forget. I have now opened the discussion of the evolution of the software development process model towards the unified process. Okay, open for all. You can do some small literature review and discuss the things openly in a debatable way, and not just copy paste operation. I expect if you can say your opinion, your suggestions, then you can put the references and get other people to do. So it's in a very open discussion on the matter that we discussed today. And then later I give another essay as an assignment for you to write. Where you will see lots of a way how the software development process models evolve. For example, there are lots of interesting things now comes, not only the agile and the other things, even how you bring the automation into the software development process, even this machine learning and the other mechanisms. So happy to hear. You can search, you can find and share them. Good discussion, and then we will see how it goes. So that's the activity from the based on that. So you can see the recorded thing, and the other one, if time permits, I will do the aspect oriented some more things, but you can discuss aspect oriented development. And then I created the essay assignment. Okay, so people can now submit what you had to do in a one page. You don't want to worry. Title, clearly say what is the challenge you are addressing. You are free to select anything. Okay, lots of interesting things, discussions were there. Sorry, I didn't have enough time to take everything, but if time permits, I'm very happy to discuss some of the observation and other evidences. Okay, always we have to justify. I think it's a very important requirement in higher education. Yeah, I mean, why higher education is different from the politics. I always say you have to see whether other people say the same thing what you do or whether they really oppose. So this is where the literature review is very, very important. It's a continuous process. So we may feel, we may understand, but then we really need to have some good evidence. Some evidence are not good. Today you have a lot of weak evidences. Okay, anybody can say anything, and they even don't go to jail. Even if you lie publicly, don't worry. How to handle the challenge in the current content. I mean, that is very, very important. All these challenges are not something impossible. People are doing a lot of things to face these challenges, and you can put some references. So this will help you to write in a small thing. So I'm not expecting a big discussion. So that's why I put in a 1 page is good. Try to be on work. That is the assignment. I put in a 2 weeks for you to do that one. Then the discussion, well, I didn't have enough time to go through here, but very interesting. If the time permits in the future, we come back. Okay, that's all what I'm planning to do today, but now it is open for you to ask anything. You wanted to get, I recorded the thing. I mean, the no harm, if you want, I can share the recording. I have the last time, you remember that my computer had a problem, I didn't record. But the first lecture also I recorded, I have those things, but we'll put into YouTube and give you that link. No problem, no harm, yeah. But I usually like not to put all these things there because I want people to come and talk because already I have uploaded the video if you want, but the most important thing, interaction. Yes. Any question, anything that you wanted to ask? I have also put in a small activity I wanted to do about the process model. I didn't have enough time to put all the questions. I'll try to add some more question and we'll ask you to do it. Probably process models, even the, I don't know how many of you know the unified process and things like that. We'll add some more questions and then we'll ask you to do it in the next time. Okay, if there is no special question, so I hope that what I explain and discuss have helped you to learn things. But remember, what I said is in a very small thing. There are a lot of things which even I don't know. I always say, lots of things I also learn. I mean, this kind of software development models are the basic things that we learn. But you have to, when you go upper level, it's something like climbing in a mountain. You have to stop and look back at what you have passed. Then you see the progress. So the software development models, evolution is very good, but there are more things to be happened. So more things will change in the future. And we have to know, we have to make sure that we are ready to face those changes. Otherwise, it will be more difficult for us, more challenging. But that's, if you know things are changing in the future, the past things could become some more stronger, or even it could become historical models. Very strong research area in the software engineering. of essay and the references both in one page. If you find difficult to put all the references in the same page, I don't mind you put the references in the other page. Okay, I understand. But even if you put it in the one page, that's enough. But because if references is one page is not enough, yes, no harm. I am not going to deduct any marks or anything. So you can put into there a little bit more, deeping more than one page. But don't go more than 2 pages at all, okay? I can't read those things. Yes. So then we will finish the session. Thank you very much for participation, and spend your time going through those things. We'll continue our discussion next week. And I'm also planning to do some industry talk series, bringing some practitioners to share their experience as part of this session. I also like that because I will also learn from them. So let's try to do that one in the coming weeks, but I'll continue this way for the next few weeks. Yeah. Thank you. So we'll stop from here.
Thank you, sir.
Thank you, Professor.
Thank you, sir.